Okay, question 16 next. Use completing the square to prove that n squared minus 8n plus 20 is positive for all values of n. Okay, let's do completing the square since they tell us to. So minus 8, half of minus 8 is minus 4. So we end up with n minus 4 squared. Now, if I was to multiply that out, I would get n squared minus 8n, and I would also get a plus 16, which I need to get rid of. So the plus 16 turns into a minus 16, so that it's not there. Plus 20, which means I've got n minus 4 squared, and 20 minus 16, or minus 16 plus 20, is plus 4. This is a positive number. This is a positive number. Therefore, this is a positive number. Okay? Question 17 then. I suppose we should write it out a bit more. So because n minus 4 squared is a square, its result is a positive. 4 is a positive number, and any positive number plus positive gives a positive answer. There we go, that's what you need to write. Something to that extent at least. Okay, let's give that a bit of... There we go. All right, so now question 17. Prove that the quadrilateral A11, or the quadrilateral made by these points, B32, 40, and D2 minus 1 is a square. Okay, what do we need to prove something is a square? We need to prove that either the sides are all the same, but then it could still be a rhombus. So all the squares are all the sides are the same, and we've got 90 degrees on the corner. Or we can prove that the diagonals intersect in the middle, or are the same length, and they cross at 90 degrees. Okay, so different options for what we've got. Okay, it might be a case if we just look at all of the lines and decide it. Let's have a quick look at what it looks like. So 1, 1 is there. 3, 2 is there. 4, 6. 3, 4, 5, 6. 4, 6 is there. And 2 minus 1. 2 minus 1 is there. That's not looking very square-like. Have I read that wrong? Oh, it's 4, 0. 4, 0. Okay, that makes a bit more sense, not 4, 6. That's why we sketch it out. Okay, so it looks somewhat square. Okay, so let's have a look at the distances. That was A, B, let's have a look at the distance of AB is equal to the square root of the difference between A and the x's here, which is 2 squared plus 1 squared, which is equal to 4, 5 square root of 5. Okay. The distance of BC is difference between there is 1 squared, difference between there is 2 squared, and already you can see that's 5 squared. Oh, sorry, not 5 squared, square root of 5. The distance of CD, CD is from here to here, 4 to 2 is 2 squared, plus 0 to minus 1, 1 squared. So again, root 5, and then finally the distance of AD. So 1 to 2 is 1 squared, and then 1 and minus 1, that's a difference of 2. So again, root 5. So they are all the same length, at least. Okay. Slope. The slope of AB is the difference of the y's, which is 1 over the difference of the x's, which is 2. Difference between 3 and 1 is 2, and it's a positive. Good. The slope of BC. So the difference of the y's, 2 to 0 is 2, and the difference of the x's, 3 to 1 is 1, and it's in a negative direction, which is minus 2. So you can see that's the negative inverse of that, making that one to be 90 degrees. Okay. The slope of CD should also be a half. Okay, so difference of the y's, 0 to minus 1 is 1. Difference of the x's, 4 and 2 is 2, and it's in a positive direction, which is a half. Again, negative inverse without making it a square root. So we've got this one is parallel, and this one is parallel, and they're both at 90 degrees. Okay, so all we've got to do is do the slope of AD, because it could still be coming in at a weird angle. Okay, making a trapezium. So at the moment I've only proved a trapezium. So the slope of AD, difference of the y's is 2, and the difference of the x's is 1, which is minus 2. There we go. That makes that a 90 degree and that 90 degrees, proving we've got a square. Okay. So again, a little bit of writing just to finish that off, to show that it is a square, now that we've done all those calculations. So all lengths are root 5, and all slopes are negative inverse of the adjacent slopes. Opposite slopes are parallel. So this makes a square. Okay. How many spelling mistakes in that? Ooh, many. Okay. Wow. What do I need? Adjacent parallel. There we go. Okay. Question 16, 17, 18, 18 next. Do I still have a mistake in that? Is that the correct spelling? Don't know. Tell me in the comments. Right. Question 18. Prove that the sum of two consecutive positive odd numbers less than 10 gives an even number. Prove that the sum of two consecutive positive odd numbers less than 10 is even. Okay, because there are not so many numbers less than 10 that are positive, okay, we're literally talking about 10 numbers, I am going to just do this by exhaustion, and I'm going to write down all of the numbers okay, so numbers that are less than 10. Straight off, that number is not less than 10. Okay, so odd numbers that are consecutive. So straight away, we can say that this is not an odd number, this is not an odd, 6 is not odd, and 8 is not odd. Okay, now is 0 odd? Doesn't make any difference to this. Well, it does, but it's not odd anyway. So here we go. We've got 1 plus 3 equals 4. That's positive. Okay, we've then got 3 plus 5 is equal to 8. Positive. Okay. Oh, sorry. Not positive. Even is what I'm showing. And yes, it is even. Where was I? 5 plus 7 is 12, which again is positive, but more importantly, it's even. And finally, 7 plus 9 is equal to 16, which is also even. So by a process of exhaustion, I have shown that all pairs of consecutive positive odd numbers less than 10 is even.